Well, hello there, and welcome back to another episode of Quantitative Bytes. So today I'd like to continue with the series that we started in the last episode, where we looked at using the SDL library with C++ to allow us to create graphical displays. Now, the motivation for me to do that was that I wanted to create some examples showing how we can use turtle graphics. So initially I just want to use turtle graphics to create some interesting displays, some nice interesting visual results. But ultimately what I want to do is to go on to explore a whole class of fractals that can be created. But the basis of those is turtle graphics. Now, turtle graphics is something that sounds a bit weird, maybe, but something that's been around for quite a long time. If you're familiar with Python, you probably know that it has a turtle graphics module that you can use to do turtle graphics that way. A long time ago, back when I was young and getting into computing, at school we were taught to do basic programming in a language called Logo, and this would allow you to control a small turtle, and you could give it a program consisting of very simple commands like forward 10, rotate right by 45 degrees, and then forward 10, and so on. And so you could build up quite complex programs. And the cool thing about this, and I think the reason it was originally called Turtle Graphics, is you could actually buy a little robot turtle, and you could plug this thing into your computer, and you could make it follow out the code that you'd actually written. So you could test it first, you could see visually on the screen what the turtle was going to do, and then you could get the real physical turtle and you could attach a pen to it, and you could put it on a big piece of paper on the floor, and you could have it draw out your pattern. And it was pretty cool, I suppose, at the time. And so it's possible with a very basic thing like that actually to create some really quite interesting visual effects. So what we're going to look at today is how we go about setting up a turtle class in C++ that will allow us to do this kind of thing. And then we're going to produce a simple example of the kind of visual result that can be made. I want to try to keep it quite short, so I don't want to give too much of an introduction. We're going to jump right in. First of all, just want to show an example of what turtle graphics is, and then we're going to dive into writing the code. So let's have a look at that now. Oh, and before I forget, if you like this video, please do remember to hit that like button, and please remember to subscribe to my channel so you don't have to miss any future videos. Thank you. Okay, let's go. Right, so turtle graphics. Well, it turns out actually turtle graphics are really very simple. So if we start with this very basic example, okay, so we're imagining here that this orange square in the center is the turtle. Apologies, my drawing skills are not really up to creating a turtle. It would have been nice. So what we can do, as I just said, with the turtle graphics system is we can give it basic commands, and we can make our turtle move around and trace a path as it goes. So in this particular example, the first command we might issue might be forward 10. If we did that, then the turtle will move forward by 10 units, and we see that's what happens here. So this is our starting position, and now our turtle has moved forward 10 units and has traced a line here as it went. The next command we might issue might be something like right 45. This would make the turtle rotate to the right by 45 degrees. So you see it is now facing in this direction. And now if we were to issue another command like forward 10, then it will move in that direction by another 10 units. And you can see that with this very basic system, you could actually start to build up really quite complex structures. Now, I didn't want to spend too long on the introduction, because I'm quite sure for quite a lot of people out there watching these videos, you're going to be familiar with this kind of concept anyway, so I didn't want to spend too long on it. But this is a very basic introduction to what turtle graphics is. What we're going to do now is we're going to look to create a class that will, in C++, that will allow us to that will represent a turtle, and will allow us to pass to it commands such as this, and we can then use those to create some interesting illustrations. Okay, so I'm going to start out with the same code that we started with in the previous episode. I'll put a link on the screen here. And so what we had in the last episode, if you remember, we fleshed out a very basic app, the very basic structure for an app using the SDL library. Then how we could, this is really a demonstration to show how we could use the SDL library to create visual displays in a window on our system with C++. And as you remember, the SDL library is a cross-platform library that provides access to the graphics hardware and audio subsystems and keyboard input and all that kind of stuff. We talked about that in the last episode, so I don't really want to go over it again. So this is in our code. We've created a file now called capp.h, and in that code we just hash include the SDL library itself. For some information about installing the SDL library, please do see the previous episode, and yes, there was some more information about that there, but everything that how to use SDL is available on the SDL website. There'll be a link in the description below. We then create a class called capp, and we give it some public methods, being a constructor, and then we have onExecute, onInit for initialization, onEvent for event handling, onLoop, onRender, and onExit. I'm not going to talk about this structure because we covered it in the last episode. In capp.cpp, then obviously we start by just hash including capp.h, and we then have our constructor function that just sets some basic things. So we set is running to true, and pointers for our window and our render are both to null. And then in our onInit method, we actually do the initialization and everything. onExecute creates an event object, and then calls the initialization method. If that returns false, it generates an error condition. If not, then we begin our main loop, and we loop through this loop forever unless is running is made false. And each time through the loop we run through all of the events that have occurred and call the onEvent method, passing a reference to each event. Once we finish that, we call the onLoop method and then the onRender method, and then we simply continue. If is running is set to false, then we drop out of that loop and we come to onExit, and then we return 0. So our onEvent method simply looks for the event SDL quit. If that occurs, it sets is running to false, which of course would make us drop out of this loop. At the moment we have absolutely nothing in onLoop and onRender, and our onExit method is really very basic. Okay, so if you have this code from the previous episode, great. If not, then pause the video where you need to and type that code up just to give the basic structure. And this is the sort of basic code that we're going to build upon. Okay. Now, the first thing that we need to do is to, once you've done that, is to create a class for our turtle. So we're going to create a new file, and we are going to, this is going to be our header file for our turtle. So we're going to do if ndef, and we're going to call our class qbturtle. Hash define qbturtle, like so. Hash ndef, those are our include guards. Okay, so I've gone ahead and saved that now as qbturtle.h, and we're going to flesh this out with some basic things. So the first thing we need to do is to hash include sdl2/sdl.h, give us access to the SDL libraries, and then we're going to create our class, which is qbturtle. Okay. Now, we need some various public things first. We need, of course, our class will need a constructor. So we specify we have the default constructor, like so, qbturtle, just like that. Now we need because we want to create a visual output, we need a method to allow the user to specify a reference to the renderer that we're actually using to do that. Allow the user to specify the renderer. Okay, so we do void set renderer SDL renderer, like so, star m_p renderer. Okay, just like that. Yeah, so just like that. And then we need methods to control the pen. Okay, so with the turtle we can move the pen up or the pen down depending on what we want. So void pen up to move the pen up when we want to move without drawing stuff, and pen down if we want to move and draw stuff. And we also have void set pen color int r, int g, int b for red, green and blue, and we'll accept an argument as well for alpha. Okay, and now we have methods to control movement. Okay, so these are going to be set angle, that's the direction that we're going to be pointing in, just like that. Void set length, so the distance that we want to move, float length. And then void rotate right by a specified angle, like so. And void rotate left, also by a specified angle, like so. We then need a method that allows us to specify the starting position. Method to allow the user to specify the starting position. Okay, void move to float x pos and float y pos, just like that. And then we need a method to actually make the turtle move. So the idea is we specify the angle that we want to move in, we set the distance that we want to move, and then we call the step method that will actually cause the turtle to move. Okay, and then we need just some basic private variables. We have to store a reference to the renderer that we're using, *m_p renderer of type SDL renderer. Okay, we also then need to store our location as mx and my, and we need to store our angle and the length that the user has specified, and then we need to store our color, so mr, mg, mb, and m alpha. And finally, we need a boolean to store the status of our pen, whether our pen is up or down, and we will store that as bool mpen down. Okay, so let's save that. So that is everything that we need for qbturtle.h. Okay, so now what we're going to do is look at fleshing out the actual C++ file for that. So we need to include some things first. We need to include, we're going to need math.h, and we will need to include std, oh actually no, I don't need that. We need to include math.h, and obviously we have to include qbturtle.h that we've just defined. Okay, so I've gone ahead and saved that now as qbturtle.cpp. So the first thing we're going to define is our constructor, and that's really quite simple. So our constructor will simply be like this. All we're doing is setting the renderer initially to null. We set the initial x position to 0 and y position to 0. Set the color to red of 255, green of 255, and blue of 255, and alpha of 255, so that's just full white. Specify the angle as 0, length as 1, and set pen down initially to false. So we then need our method to set the renderer, so that is very simple, just like that. So this is qbturtle : set renderer, and the user passes a reference to the renderer object, and we simply copy that into mp renderer, like so. And then our methods to handle pen up and pen down are also very basic. Okay, very simple, nothing complicated there. Likewise, set pen color. So set pen color, we simply do that, except to red, green, and blue, and alpha as inputs, and then store those accordingly. Okay, and set angle and set length, also really very basic, so not much to talk about those. Feel free to pause the video at any point if you want to follow along and type these out. So set angle simply accepts the angle as a float as input and stores it into m angle. Length, of course, accepts the length as a float input and stores it into m length. So that's all fairly straightforward. Now, the interesting thing, a little bit more interesting now, let's just put some blank space in there. So we're going to define our methods for rotate, qbturtle : rotate right float angle. Okay, so what we're going to do here, now in this case the user wants the turtle to rotate to the right, so we simply, from its initial angle, so we're not specifying what the angle is, we're specifying the angle by which we wish to rotate from the direction we're already pointing. So we do m angle minus equals, because it's float going to the right, angle that's just been specified, multiplied by m_pi, which we get from math.h, divided by 180.0. So all that does is simply convert the angle from degrees to radians. So we're assuming that the user has specified this angle in degrees, and so we multiply that by pi divided by 180 to convert to radians. And then very simply, we do the same thing again for rotate left, float angle, only this time it's plus equals m, if I could type, m angle plus equals angle multiplied by m_pi divided by 180. Okay, and that's all we need for those. Right, and then we need, yes, okay. And then the last method, if we look back at qbturtle.h, the last method that we haven't defined is step. So this is the one that actually causes the turtle to move. I just want to check we did define everything else. No, we didn't. But what I haven't defined yet, apologies. Okay, yes, move to. Okay, my apologies. We also need move to, so I'm just going to put that in there. Just copy and paste. So move to accepts xpos and ypos as float inputs and simply stores those in mx and my. So really very basic. And what I want to focus on now is the step method. So this is going to be void qbturtle : step, like so. Now, the first thing we need to do, we need to compute, first of all, where the turtle is going to end up. Compute where the turtle will end up. So what we're doing is this will cause the turtle to move from where it is now in the direction that's been specified by the angle, by the distance that's been specified by length. So we simply do float start x is equal to mx, that's our starting position for this move, and start y is equal to my, just like that. And now we need to calculate end x and end y. So end x is going to be start x plus the cosine of our angle multiplied by m length. And if you think about the basic trigonometry, you will see why that is the same. Now we do now we do this exactly the same thing for y. So we have end y is equal to start y plus sine of m angle multiplied by m length, just like that. Okay, and then we need to actually move the turtle to the new position, but at this point all that means is we store mx equals end x and my equals end y. So all that means is we simply have to store that. Now, if the user has specified a renderer and the pen is down, then we actually want to draw stuff into that renderer. So what we need, let's just put in some comments. If a renderer has been specified and pen is down, then draw stuff. Okay. So we do if mp renderer is not equal to null, okay, and m pen down is true. Okay, so in that situation now we know that we need to draw stuff. Okay, so what we do is we do SDL set render draw color and specify the pointer, the reference to the renderer, and then pass mr, mg, mb, and m alpha. So we specify the color that we want to draw in, and then we're going to call SDL render draw line into MP renderer, like so. I'm going to divide this over multiple lines just for tidiness, and we need to do static cast to int round start x, okay, and to static cast int round start y. So we're drawing a line from start x, start y to static cast to int of round end x, static cast to int round end y. Okay, so that will draw a line into the renderer specified by this pointer from start x, start y to end x, end y, and that is pretty much everything that we need. So we simply then close that curly brace. If none of those conditions are met, then we actually don't have to do anything. So let's go ahead and save that. And that is, I believe, we've covered everything. Pen up, pen down, set pen color, set angle, set length, rotate right, rotate left, move to, and step. So that is everything we need for our turtle class. As you can see, it's really very simple. Okay, nothing complicated there at all. Like I say, feel free to pause the video, have a look at that code in more detail anywhere if you're not sure what's going on. Okay, so what we need to do now is to actually make our turtle do something. And to do that, we're going to, first of all, go back to capp.h, and we are going to define our turtle. We first of all need to, after here, we need to do hash include, and we're going to include qb turtle.h, like so. And then down here in our private members, we're going to create an instance of our turtle class with qb turtle m turtle, just like so. So that's everything we need to change for now in capp.h. And then in capp.cpp, we are now going to use our turtle to actually create something initially very simple. Now what we're going to do, because this will loop through on loop and on render an infinite number of times, or at least until the user closes the window in order to quit the application, we don't really want that to happen. What we want to do is simply just draw something once and then just be able to see what that is, and then just leave the window on the screen so the user can see. So in order to do that, we can put our code into the onInit method. So this is the capp : onInit method, and we can simply put our code in here in order to do something with our turtle. So the first thing we're going to do is, yes, let's initialize our turtle. Okay, oops, if I could spell. So we're going to initialize our turtle, so qb turtle m turtle, like so. And then we're going to call mturtle.move to 320 by 240. So we know that our window is 640 by 480 pixels. So we're going to move to 320 by 240, which will put us in the center. Okay. We then need to set the background set the background color to black. Okay, just to make sure the background of our window will be black, and we do that SDL_set render draw color, like so. P renderer is the pointer to our renderer, and then black 0, 0, 0, 0. That's red, green, and blue are black, and then maximum alpha 255. And then we simply call SDL render clear and pass the pointer to our renderer. So that will clear our window with black. Now we need to actually do something. In fact, let's just pause there. What we're going to do is actually check that that works. And we're going to just change the name of our window here. So in this, where we have SDL create window, turtle graphics test. Okay, just like so. Okay, let's save that. Before we can actually do anything with this, before we can compile it, we also, of course, need main.cpp. Okay, so I've already gone ahead and defined that. Main.cpp is only 7 lines. All we need to do is hash include capp.h, and then we have the standard int main, and then capp the app, and return the app.onExecute. Just that is in our main. So this is our main entry point for our code. Okay, we can't really compile anything. In fact, well, not at all without that. Okay, so go ahead and save that. So that's main.cpp. Right, so at our terminal window, we see we have all of these files here now. So to compile everything, we just do g++ -o main. That's the name of the file that we want to create. We want to compile main.cpp. We want to compile capp.cpp, and we want to compile qbturtle.cpp, and then we need -l_sdl2 to tell it to link against the SDL library. So if we run that, that should hopefully work. Okay, very good. And then we can simply run main, and we get exactly what we expect. Very simply, we get a black window that says Turtle Graphics Test on it. Okay, so we know everything is working. Let's close that for now. Now let's actually do something with our turtle. Let's go back to capp.cpp, and then just here, underneath where we set the background color to black, we're going to do stuff with our turtle. Okay. So first of all, we need to tell our turtle where it's going to render things. So call mturtle.set renderer, and we pass to it the pointer to our renderer. So that's basic. And let's put the pen down so that we draw stuff. Dot pen down, like so. And then let's specify set length to, I think, 75 pixels. And yes, so angle is already set. We'll stick with the default angle. If we simply call turtle.step, just like that. Now let's compile and run that code and see what happens. So back to our terminal window. Okay, let's rerun our compiler and rerun our code. And for some reason, it doesn't do anything. Yes, of course. So, and we find that doesn't do anything. And of course that is because I've made a rookie mistake. We have to actually update the window. So we need to do SDL render present and pass to it the pointer to the renderer. So this has to come at the end after we've done all our stuff, and that will cause it to actually put stuff to display the image. So back to our terminal window, let's rerun the compiler. And run our code, and there we go. So what we see now is we simply get a line that is along this particular direction. The initial angle was set to 0, and it is 75 pixels long. Just have to take my word for that. So that was simply when we call the mturtle.step method, then we draw that line. Okay, well that's really not very exciting. I can almost hear your skepticism as you're kind of thinking, ooh, well, what's so interesting about that? And you're right. Nothing is particularly interesting about that. Now where it starts to get a little bit more interesting is if we now start to do some kind of looping thing. So we can do, for example, let's create a loop here. Let's call it int j equals 0, j less than 8, j plus plus, and create a very simple for loop. And what we're going to do inside our for loop is we're going to do mturtle dot rotate right 45 and then mturtle.step. So what's going to happen every time we come through this loop, the turtle is going to rotate to the right by 45 degrees, and then it's going to call step, which will force it to move 75 pixels in that direction, and then it's going to repeat that process again. So let's have a look what that looks like. If we save that and then back to our terminal window, now let's rerun our compiler. Okay. And let's run our code and see what we get now. And we now see, there we go, we now see that we get an octagon. So our code has started here in the center, and we've rotated 45 degrees, and we've drawn around this way. Okay. Yes, I did specify rotate right, but it has actually rotated to the left. okay. So maybe those are the wrong way round. Yes, never mind. It doesn't matter. Well, in fact, let's actually just fix that because I specified rotate right. So let's go back to qbturtle.cpp, and here we have rotate right and rotate left. So we're going to change that from minus equals in rotate right to plus equals, and then in rotate left we change that to minus equals. So let's save that and look back at capp.cpp, and let's compile our code again and run it. Yes, and there we see. So we started from here. This is the center of the screen, and then we've rotated right, which would correspond to clockwise by 45 degrees. We've moved to here, then we've rotated 45 degrees again to here, and moved forward by 75 pixels, rotated 45 degrees, forward by 75 pixels, rotated by 45 degrees, forward by 75 pixels, and so on. So yes, I think you get the picture. Okay, so very simple, but it's beginning to show the potential that Turtle graphics have to do something interesting. So in order to make this a little bit more exciting, we are going to define another loop. Okay, so we're going to do int I equals 0, I less than 18, I plus plus. Okay, let's put the braces in and just sort out our tabs because we like to keep things neat, like so. Right. So now what's going to happen is, in fact, we're going to repeat this 18 times, but if we simply did that 18 times, it will just draw the same thing again each time, and that's really not very interesting. What we want to do is here, outside of the inner loop, or mturtle.rotate left 20. Okay, so each time around the outer loop, we're rotating left by 20 each time, and then the inner loop is exactly as we had before. So if we save that, go back to our terminal window, let's rerun our compiler. run our code, and immediately we start to get something really much more interesting. It starts to look really cool. Okay, so all we've done is that's simply from repeating. Let me just change that around. No, I don't want the terminal window. I want to see the output. There it is. Okay, so all we're doing is in this inner loop here. Yeah, okay, I can't do that, of course. Right, so this inner loop here simply draws the octagon that we saw before with 8 sides. But then we're actually got an outer loop that draws 18 of those octagons, but rotates the position, rotates the angle of the turtle by 20 degrees to the left each time before drawing each new one. And simply because we're always starting from the angle and the position that we were at previously before, then we actually start to get this really interesting pattern. Now there's one last thing I want to do. It's coming close to what I think is probably enough for one episode on this. We can actually give this some quite funky colours, which I think starts to look really quite cool. So we want to go back to capp.h. So in capp.h we are going to define just some extra things to help us handle some colours. So what we're going to do is create 3 arrays of integers using std vector, and we're going to have a list of colours, a list of values for red, and we're going to create a list of values for green, and we are going to create a list of values for blue, just like so. Okay, so save that, drop back into capp.cpp and capp.cpp. So in the constructor here, now we just need to define what those colors are going to be. So forgive me for copying and pasting this, but you really want to type it all out. But you can pause the video and have a look. So these correspond to the orange, yellow and blue colors that I use for my channel branding, which happen to look quite nice when we use anything. So we simply define the 3 colors. So we see we have red of 51, green of 128, blue of 204 is one color, and so on for the others. Okay, that should be easy enough to understand, I think. Now what we need to do is put in some code to actually change our color, and we're going to do that here. So we're going to change the color for each of our octagons. So we simply call mturtle.setPenColor, that's what we called it, and we're going to query into mRedList. Now we're going to do I modulo 3. Okay, so I loops from 0 to 18, but we can only go from 0, 1 and 2, and then we need to go back. So if we do I modulo 3, we will get that. And then we do the same for mGreenList, I modulo 3, and mBlueList, I modulo 3, just like that. And we leave alpha as 255 because we don't want anything to be transparent. So if we save that, and let's go back to our terminal window, we're going to run our compiler. Oh, I've made a mistake. Yes, I know what I've done. My fault. In capp.h, yes, in capp.h, just here, we need to hash include vector so that we bring that in from the standard libraries. My fault, apologies. So that's capp.h hash include vector. Okay, so if we go back to our terminal, let's just clear that and rerun our compiler. It should be in business now. Yes, let's run our code, and there we go, which I think is really quite a pleasing result. So all we've done is we're simply drawing 18 octagons, and as we go round the different octagons we are cycling through the 3 colors, and I think that starts to look really quite cool. And I think you can see that you don't need to do too much. You can alter these parameters, alter these angles, and you can create all sorts of interesting and different effects with that. But I think that's quite cool, actually, just like that. So there we go. That's really everything that I wanted to talk about today. We have very quickly created a really simple class to handle our turtle, and this allows us to implement what's known as turtle graphics. And we've seen how from something very, very simple, we can simply create a list of rules that we can then put into loops, and we can use that to create really quite complex and I think really quite aesthetically pleasing looking images. Despite it being very simple, we can actually get some quite nice results there. So yeah, Have a play around with the code, adjust the parameters, change the angles, the step lengths. You can do all sorts of things and create some really amazing designs. So really just have fun with it. I had quite a lot of fun putting this together, as a practice run before making this episode. And yeah, it's really quite enjoyable, I think, if you like that sort of thing, I suppose. But I guess I do. So there we go. What I want to do next now in the next episode, after this, is I actually want to use the turtle graphics to do something, I think, which is quite a lot more interesting. This is aesthetically pleasing, but isn't particularly exciting on its own. And I want to go on to explore the range of fractals and fractal curves that we can create using the turtle graphics method, which I really hope will be interesting. So yes, anyway, I really hope you've enjoyed this episode. If you've liked it, please do remember to hit that like button. And please remember, if you haven't done so already, to subscribe to my channel and hit the bell icon so you receive the notifications so you don't have to miss any future videos. Listen, it's been a pleasure. I really hope you've enjoyed this video. Thank you very much for watching, and I really look forward to seeing you in the next video. Bye.